All right, ladies and gentlemen, today's video is going to be a little bit more of our exploration of matter, specifically looking at some of the ways that matter can be organized. So we mentioned already that matter can be elements, matter can be molecules, matter can be compounds, and it's that variety of matter that creates the infinite variety that we have within the universe. But what you also have to understand is that those different types of matter can be combined in different ways, or they can exist separately. And so just a real quick checklist for us to think about. So if you have atoms of only one element, and you could have millions of atoms of only one element, billions, trillions, numbers that are too big for us to really wrap our head around, that's a pure substance. If you have molecules or compounds of one type, and again, you could have millions of these molecules, billions of these compounds, but if it's only one type of molecule or one type of compound, we call that a pure substance. If you have atoms of more than one element, so if you had carbon atoms together with hydrogen atoms, now, not connected. I think that's actually a key thing to think about here, is that the atoms are not connected to each other, but rather they're just existing together. That, when you have more than one element type, is called a mixture. And if you have multiple types of molecules or multiple types of compounds, again, existing together, but, like we said before, not connected, we also call that a mixture. All right? And in fact, for a mixture, you could even do atoms and compounds in any variety of ratios. And because they're different, it's going to be a mixture. So let's actually take another look at this in a little more graphical way. So here we have this, diagram that we can look at. And you can see in this diagram, so we have atoms, molecules, pure substances, compounds, pure substances. So let's hit on a couple of these key terms in here. All right. So first off, you know what an atom is at this point. You know what molecules are. You know what pure substances are. So here you see this term monoatomic. All right, that means atoms, or rather elements, that are one atom alone. And that makes sense if you think about the prefix mono, okay? Now, a couple other things. Here you can have diatomic or triatomic. So what these are two or three atoms combined. Now what you'll notice is that these are what we use when we reference the term molecule, but they are the same element. Okay? Now, in addition to diatomic and triatomic structures, which we refer to as molecules, we also have compounds. And you'll notice that the thing about compounds versus molecules is that they're different types of atoms. So in a diatomic substance, you could have O2, which is two oxygen atoms combined, and that's an oxygen molecule. A triatomic atom, or a triatomic structure, you could have O3, which is three atoms of oxygen, and that's a ozone molecule. But with a compound, they're two different things. So, for instance, CO, carbon and oxygen, makes carbon monoxide. That's a compound. Sodium chloride, sodium and chlorine combined together. That's a compound. All right. The difference between compound and molecule is molecules are the same element, compounds are different. But you'll notice here in this diagram, here it says one type of either. So if you have only one type of molecule, that's a pure substance. If you have one type of compound, that's a pure substance. And you'll notice here, an atom, pure substance if it's monoatomic. All right, so this is basically what we just talked about, but it's a nice little flow chart to sort of try and get those ideas in your head. The one thing that I do want to address here is this new term referred to as an isomer. An isomer is a compound that basically has the same formula. So let's use this as an example. C3H8. All right, so that can look like this. And that's basically the only way it can look. All right. But let's use another example. Let's say C3H8O, which is commonly known as propanol, or rubbing alcohol. And that can actually have two different structures. It can look like this. Which is very similar to the C3H8 we just drew. Or it can look like this. I still have my carbons in the chain, but I moved this OH right here. I moved this OH to a different spot, and that moves the hydrogens around. And these two versions of propanol have slightly different properties. Okay? See this different arrangement? That means different properties. Okay? That's the basics of what an isomer is. So here we have all the different types of pure substances. Atoms by themselves can be pure substances. Molecules by themselves, if you have only one type, can be pure substances. Compounds by themselves, if you have only one type, can be pure substances. And compounds can actually also be isomers, which are the same exact chemical formula but have a slightly different structure. Now, what gets weird is when you take these pure substances, you'll notice here I have pure substance 1, pure substance 2, and what happens is when I mix them together, I get what's known as a mixture. All right? Now, the thing about a mixture is, one way or the other, it can always be separated. Okay? It's not always ideal, it's not always easy, but if it can be separated, if it's a mixture rather, it can be separated in some way. Now, there's two types of mixtures that we have here. You have a homogeneous mixture and a heterogeneous mixture. Now, homogeneous mixture, the prefix homo means same, and the prefix hetero means different. All right? So homogeneous mixtures, basically what happens is when you mix them together, it looks like it's just one thing. It looks like it's a unified substance. In a heterogeneous mixture, when you look at it, you can actually see all the different parts. The common example we generally use for a heterogeneous mixture is a salad. So if you take a look at a salad, you could see the lettuce, or the tomatoes, or the chicken, or the croutons, whatever you want to put in it. They don't like blend to become one thing. You can still see each of the individual pieces. And that's sort of what happens when you have a heterogeneous mixture. With a homogeneous mixture, the pieces tend to disappear into each other and look like a new thing, but it's still a mixture. The common example that we use for that is salt water. All right. Now, within homogeneous mixtures, there's basically two separate types. You have solutions and colloids. Now, solutions, the substances mixed together completely to form a clear mixture. Okay. Colloids, however, you'll notice the mixture is slightly cloudy. Now, sometimes cloudy is blatantly obvious, like milk. All right, you can see that it's cloudy, and milk is a colloidal suspension. But what you also might notice is sometimes the cloudiness isn't as obvious, and that's why we care about that definition that we did in your definitions when we were going over vocabulary. That was called the Tyndall effect, where basically if you shine a light on a colloid, it will reflect the light. Whereas if you shine light on a solution, it passes right through it. And the best way to think about where you see this is with fog. Fog is a colloid. It's water particles suspended in the air among all the gases. And so that's why you're never supposed to use your high beams, because it diffuses the light and you can see it. That's actually the Tyndall effect. All right? Like we said, suspensions and substances don't mix. So we've got solutions, colloids, and suspensions as the different types of mixtures. So that's the basics of some of the ways matter can come together and the differences between pure substances and mixtures.